Hey class, in this video we're going to be talking about loops using JavaScript and P5. Loops are one of the basic programming concepts that we are going to cover this semester. They're used in pretty much every programming language as a way to repeat actions in your code. And so we'll look at a few different ways to create a loop and then how to do some drawing with the loops. And we'll start working on a project that we'll do a couple versions of where we're going to create patterns that combine loops with randomness to create variation, what's called generative patterns or designs. So let's get started. I'm going to open up GitHub desktop, switch to MMP 210, and make sure I'm up to date, and then open in the Finder. We're going to be starting a new project today. So this will be my first pattern that I'm going to create. I'm going to create a new folder and call this pattern version 1. We should have at least 2 of these. So let's copy over a style sheet, an index, and a P5 library to get started. So I'm just going to go to another project and copy these 3 files. So I can do command copy and command paste. Another way to do it on the Mac is to hold the Option key and then drag like that. You'll see the little green plus, and so that means it'll make a copy. So we can see that those files are still in here, and now they're in my new pattern folder. Then I'll take the project folder and open up in Sublime. And I'm going to start just by editing index.html. So this new project is called pattern version 1. And we'll change the header here as well. And so that looks good to start. I'm going to create a new file for my sketch.js. So I'll do command N and save as. And this is sketch.js. Make sure it's in that pattern version 1 folder. And I'll make a comment and just say pattern version 1. JavaScript loops. I'll make a quick function setup. Create a canvas using the dimensions I usually use. And then we'll create a draw function with our background. And we'll do another light gray background, so just our typical setup. I'm going to start the Sublime server and open a new window. Localhost 8080 and MMP 210. And I haven't added this link yet, so I'm going to type in the URL, pattern v1. And let's get the console open. That looks good. And so now we're ready to go. Let's start talking about what a JavaScript loop is. And so a loop is kind of like another type of control structure. We also have the if, else if conditional control structure. So notice that there's some similarities, right? We have a keyword. So instead of function, we have if, followed by parentheses, where we include our conditions, and then followed by curly brackets, which contain the code that will execute if the condition is true. So the main thing here I want to point out is that when we create curly brackets, we're kind of creating a new scope or a new little area for our program. And that is generally referred to as a control structure. So it's something where we put some code and then we control when it gets used. So a loop is a bit like an if statement, but it's like an if statement that happens more than once. So I'm going to demonstrate an if statement just in our code, not inside of any of our functions for now. And I'm just going to use the console for a second. So when we have an if statement, we normally start with if, and then we have a parentheses with our conditions, and then some curly brackets with the code that we want if our condition is true. And so let's start with a condition. I'm going to start with a variable. I'm going to call it I, just for now. You'll see why in a bit. So I'm going to say variable I equals 0. I'm going to say if I is less than 5, then let's console.log I. And so with this structure, we'll see that we're just going to log I once. So if I reload my page, you can see there's I, it's just 0. I can put a little string here so we can label that I is 0. Okay, and so if I do anything, like let's say I increase I, I'm going to say I++. Now I is 1, but that's kind of all that happens. So when we have an if statement, it just does it once, regardless of what the condition is or what happens inside the if statement. So as long as this is true, then we're going to log I. If we set I to 5 to start, then when we do that comparison, 5 is not less than 5, right? Because they're the same value. And so now nothing happens in the console because I is less than 5 isn't true. So let's return I to 0. And now I is 1. In order to do a loop, all I have to do at this point is change this little if into a new word, while. And you can probably guess while what it means here. If you just think about the meaning of the word while, we think of while as like a period of time or, while you're waiting for something. And so in code, we're saying while this thing is true, keep doing this. So as long as, or while I is less than 5, keep adding 1 to 5 and then logging 5. And so now we'll see the difference here is that instead of just doing it once, now it logs I 5 times. And so that's not very exciting, but you can start to imagine, well, there's a lot of stuff I could do if I could repeat a bunch of code as many times as I want to. There's no limit to how many times we can do a loop. If I say I is less than 100, we'll go all the way up to 100. There are probably some limits on huge numbers, but for our purposes, there really is no limit to how many loops we can do in any given context. So the while loop is a simple type of loop. It's not the one that we're typically going to use in class, however, and there's a few reasons for that. The main one is that it's just a little bit more dangerous. So for example, if I take out this I++, what we're going to have is a bad pattern, because basically what's going to happen, you might be able to guess this, is that since it's a loop, if 0 is less than 100, that's true. So then we're going to console.log I. And then because it's a loop, we're going to go back here. The problem is I hasn't changed. I is still 0. So 0 is still less than 100, and that's true. And so then we loop it back again. And you can probably guess that because I++ never happens, I never changes. And so this statement is never false. And we really need the statement to be false for a loop to work. That's kind of how a loop works, is we create a statement, a condition that's true, and then we count up until it's false. And you can count in a lot of different ways, but the main thing is that if you never reach false, you're going to enter what's called an infinite loop or a Stack Overflow, and you'll crash the browser. It's not the end of the world, but it could be really bad in other programs if you do that. And so partially because we want to avoid that, but also just because it's a nicer syntax, what we'll use instead is called a for loop. And a for loop is really simple. We already have everything we need here. It just places them into the same place. So if we wanted to make the same thing with a for loop, I would say for. So notice with my while loop, my I condition is before the while keyword. But with the for loop, all of our conditions come after the keyword. So with for loop, we have our 3 conditions, the I equals 0, the I is less than 100, which is the ending condition, and then the I++, which is the increment or the changing condition. And we just put those all next to each other. So the variable I equals 0 goes first, I is less than 100 goes second, and then we need a semicolon, and then I++ goes last. And for that one, we actually don't need a semicolon at the end there. I'm not sure why, but I guess it just looks syntactically better. And so then we can do whatever it is our code is doing, and the rest of this stuff we can just ignore. So I'm going to take that out. So with a for loop, our code happens here, and the loop happens here. So it's a little bit safer. We can see all our conditions together in the same place, and we don't have to worry about forgetting to do something with I or doing something weird that changes I and creates an error. So now we see we have the same result, that I counts from 0 all the way up to, in this case, 99, because I was incrementing I before I was logging. And so if we wanted to get up to 100, I could just change this to less than or equal to 100. So that way, when I gets to 100, this will still be true, because anything that's less to or equal to 100, it'll still go through my code. So now we get up to 100. So one thing that you'll probably see when you're using loops, I'm going to delete this for a moment, is the let keyword. We haven't really talked about this before in class, but let essentially is the same thing as var, but it's scoped to this context. And so I'll show you what that means. So if I have variable I equals 0 and I do a bunch of stuff, and then when I'm out of my for loop, I'll console.log what is I now, and I'll log I. So if I use var, I is still going to exist once we leave our for loop. So I is now 101. Okay, that's not the end of the world, but if you're working with a large program that has lots of different loops, you might run into issues with that. So what we have instead is let. And let does the exact same thing as var. It declares this variable called I and assigns it to 0, or assigns 0 to the variable name. But in this case, let only exists in between these two curly brackets. So I can use I here, but here I'm going to get an error. So we see uncaught reference error. Okay, so basically, as soon as we get out of this for loop, I no longer exists. That's the advantage of using I, is that now I can do another for loop, or I can do something else with I and not have to worry about using the same variable there. So that's just a little bit on the scope. Again, when we're inside curly brackets, whether it's in a function or an if statement or a for loop, we have this thing called scope, and variables that exist inside here don't exist in other places except for in special instances. Now that we've created our for loop, it's important to notice that we don't always have to count by 1, although that is often the case. We can also count by other numbers. So instead of plus plus, which is counting up by 1 each time, we could also count up by like 10. So if I did this by 10, I go 0, 10, and I still get to 100. As soon as I get to 100, the next value of I is going to be something like 110, and that is going to evaluate to false here because 110 is greater than 100. So I is no longer less than or equal to 100. So we can count by greater intervals. We can also start wherever we want. So we could start at, I equals 50. And then we would just count from 50 up to 100. We could also start from negative 50. You do want to be a little bit careful here because you do have to make sure, even with a for loop, that you don't have some instance where I never reaches a conclusion based on the increment statement. So that's a thing to watch out for. We can also count backwards, but then we kind of have to reverse engineer everything, right? Like I could start at 100 and I could subtract 10 each time. But then I have to be careful because if it starts at 100, well, in this case, it'll never be greater than 100 because if I subtract 10 each time, I just keeps getting smaller and smaller, and then I'll never get out of my loop, so I'll crash the program. So I have to make sure to say greater than or equal to or greater than or whatever I want, and then change this to something smaller like 0. So now I'm counting backwards, starting at 100 and going down to 10. Or if I want it to go all the way down to 0, I say greater than or equal to 0. So with loops, it's just important to realize that this piece of code is happening over and over again. It doesn't necessarily have to just be a console.log. We'll see when we add this to our P5 that it can be shapes or anything else. And it's also important to realize that this statement, you basically kind of have to think of this as like the opposite of what it sounds like. Okay, so let's go back to our regular counting up loop. So I equals 0, that's where we start. We add 10 each time we go around the loop, and then we keep doing it until I is greater than 100. But what we're really evaluating is whether or not I is less than 100. So every time that hits true, then we keep going to the rest of our loop. So if I were to write this out without using a loop, this is what it would look like. It would start with let I equals 0. And then the very next thing that would happen, even though there's a bunch of other stuff that happens here, is it actually just goes straight to console.log. So then we get the I is 0 in the console. Show that that's a console. So then the next thing that happens is we do this. We do the increment statement. So then we'd say I plus equals 10. Okay. So I now is equal to 10. And so then we would check to see so then we check our condition over here. So 10 is less than 100. and question mark because that's a condition. That's true. Okay, so then we log I again. So we go I is 10. Okay, and then we go back to the beginning of the loop. So then we say I plus equals 10. So now 20 is a result of that. So is 20 less than 100? Yes, that's true. And so then we log 20. And then we just keep going over and over and over until at a certain point, I will be equal to 110. And so then when we do that math, is 110 less than 100? That's false. And that's the point at which the loop stops. So it's a bit confusing at first, but as you use more loops, you'll start to get used to it. So let's stop doing just a theoretical explanation with code and see how we can use this in our draw function. So last week, there was actually a good example of this, or maybe it was 2 weeks ago, where I was drawing a bunch of different circles, and I had to copy and paste that ellipse code over and over and over again. And that was a little bit silly because you could see, I just wrote ellipse like a million times. And so that's kind of what a loop is good for. So we can imagine, like, if I wanted to draw 5 ellipses on the screen, if I said like ellipse 100, 100, 100, something like that. So now I have one ellipse. If I want to draw a second ellipse, I might just copy and paste this and move it over on X. Okay, now I have 2 ellipses. And then I would copy and paste this and move it over again. Now I have 3 ellipses. And if I do that again, I now have 4 ellipses. And finally, if I do it one more time, I've got 5 ellipses, right? So I have 5 lines of code, and literally every single line is exactly the same except for this one little number right here. So if you ever see something like that, whether it's going across the screen or up and down the screen, or even like with a color or something like that, if you ever see that you use the same line of code or something close to the same line of code, and you only changed one thing each time, then that's a good sign that you probably want to use a loop. Loops are useful for a lot of other things as well, but this is a really good sign that what you're doing could be recreated with a loop. So let's think about this and think about how we could recreate this with a loop. So first of all, if we want a loop, we're going to need some variables, right? We can't just like repeat this over and over again. So we need something that we can change here. These guys, these don't change, so that's fine. We don't have to worry about these. But these guys, the x value changes each time. So if I have something that changes, then I need a variable. So let's start with a variable. I'm going to say let x equal 100. And so then x could go in here, but once we get to here, that's not going to work anymore. Our second circle is going to disappear. It's really just on top of the first circle. So what we need to do is add some to x. So I can say x plus equals 100. Now we get our second circle. And now we can see that that's the same thing that we're going to do each time with this ellipse. So if I just add 100 to x every single time, then I can use x and I can repeat my code. So now each one of these ellipses is exactly the same. And so now I can put it in a loop. So let's turn this into a loop. So we'll say for let x equals 100. And keep in mind that with a loop, it often starts with I. I stands for index, but it's also just one of the keys on the keyboard that was free to use for iteration when programmers were first coming up with these types of concepts. But basically, I can say, let x equals 100. If I want to make 5, then I just have to choose a number that will give me, 5. So I can do that math in my head, or I can just try something and then fix it later. So I know that the last one, so if I say x is 100, 200, 300, 400, 500. So I've got to get at least to 500. So then I can use 501 as like kind of the cutoff point there. You could use 502 as well, as long as you don't go up to 601, then you'd be fine. But it also doesn't really matter. Like if you draw 6 ellipses, that would probably be fine. But I need at least 501. If I went with 500, I'd only have 4 of my ellipses. So then I just increase x each time, and I can just cut this here and paste it there. I don't need the semicolon at the end. I'm just going to put a little parentheses here, and then I have my curly brackets, And now what used to be 5 lines of code is basically 2 lines of code if you don't count, this one curly bracket. And we also can change a lot of stuff without having to, change a bunch of different lines of code. If I want X actually, I want it to actually start at 0. Okay, that looks good. I want it to actually go all the way to the end of the canvas. So let's make that 640. And I know that there's a variable for that, so I'll use width there. Maybe I want the X's more spaced out, so I can increase the increment value, or I can, change it a little bit. And then I can change the size. If I want all the circles to be smaller, I can make them all smaller just by changing this number. If I want to change all the Y values, I can change all of the Y values just by changing that number. So you can see that with using a loop, all of a sudden I have all this control over what I see on my sketch without having to edit, 8 different lines or 5 different lines of code that are just basically kind of repeating the same information. So it's important to realize, like, if I did want my circles to be like, all over the place like this, then maybe you should write each circle individually. But if you have a pattern, if you have something that's repeating and there's similarities across the pattern, then you probably want to use a loop. I'm going to put height over 2, so this will just be centered, but I should spell height correctly. And I can go back to 100 here. Doesn't make a huge difference. And so yeah, once we're inside of this loop, we kind of have this like new part of our code where we can add lots of different stuff. So if I want to make like a little tiny self-portrait, I could say like, this is my face. And if I want to repeat it a few times, then I can actually just keep adding code. So I'm going to like paste this and make an eye. Okay, maybe make it even a bit smaller. And move it over a bit, like -20, or maybe -10. And then I can copy that and say +10. And so now I have like a little face with 2 eyes, and I can, make more or less of them. I can do different stuff with them. So once I'm inside of this for loop, I can add lots of, code in here. The one thing I want to be careful about is that I use this X, because if I don't use X, like if I use just variables like 100, then all of my eyes are right here, just repeated, because X is kind of what's changing as we move across our loop. So that X value starts at 0, right? Let X equal 0. And then as long as X is less than width, which is all the way over here, we do plus equals, what did I do? 100 each time. So then X is 100, X is 200, X is 300, X is 400, 500, and 600. And so each time we draw our circles, we need to make sure to use that X value so that whatever shapes we're drawing actually, match with each other in terms of their X position. So if I put X and X here, now we're back to our regular circles, our regular self-portraits. So now, what can we do with this? We can make some patterns. We can do some small variation. In the second video, I'm going to show you guys how to do a lot more variation. But for now, let's just deal with the types of variation that are easy to do. And so what I'm going to do is I'm going to make like a landscape. So I'm just going to create a few different shapes and try to create like a landscape. I might add some variation just as an example as we go through. So if we want a landscape, let's think about a few things that we could do. We could do some clouds, we could do some trees, and we could do some mountains. So let's start with mountains. That should be pretty easy. I'll use some triangles. And when you create your own landscape, or if you want to do a separate pattern, that's fine as well. Come up with your own version of this. I don't want to see more mountains and triangles and stuff. So let's start with our mountains. Okay, so actually, I'm going to end up using multiple loops for this. So I'm going to start with a landscape, and let's start with our mountains. And so I'll do like a triangle. And so remember, the triangle is XY, XY, XY. So we'll start with X for the first one. I'll put Y pretty close to the bottom, so I'll say like height minus 100. Or actually, let's put it all the way at the bottom to start. And then we'll move over a bit on X, so I'll say like X plus 50. And then Y will go up a bit. So let's just say like 200. And then we'll move a bit farther on X. Let's say X plus 100. And then we'll go back down on Y to complete our little mountain shape. Okay, that looks okay. I want to maybe move this Y up a bit. And maybe I want the width to actually be a bit bigger. So let's put like X is 200 here and X is... Okay, that kind of looks better. Now we're starting over here, so I'm going to move this X back a bit. Okay, that kind of looks nice. Let's do a little fill here. We'll say fill is green. Okay, that's starting to look like mountains. And maybe let's make our stroke brown or something like that. So, and stroke weight is 10. And it looks a little nuts. Let's move the Y down a bit. So I'm going to say like height plus 20. And then maybe actually we flop the maybe we swap these. The fill is brown and the outsides are green. It's a little, you know, we could say this is kind of like an abstract mountain. We're just kind of making a pattern, so it doesn't really matter that much here. We could also, you know, take out the strokes if we wanted to just have like a silhouette of mountains. That might look a little bit better. But it depends on what your style that you're going for is. So I'll stick with this for now. I might bring the stroke down just a bit. So we have our mountains. So we could add more in here. Like if I wanted to add a tree, I could add some rectangles or something like that. But then we'd have to kind of like match them. So let's just make another for loop for our trees. So we'll say trees. And so for this time, I'll say let x equals 0. X is less than width. So I'm going to use kind of the same thing here. And then x plus equals 20. So I'm going to make my trees a bit smaller. And so first I'm going to draw the rectangle for the tree. So I'm going to say fill is brown. So this will be like the tree trunk. And no stroke. And so I'll draw a rectangle. I'm going to use rect mode center so I don't have to match up the rectangle and circle. So I'm going to say rect at x, and for y I'll say height. Or actually let's say height minus 100. Oops. And for the width I'll just say let's say 10. Maybe we'll change that. And then for the height we'll use 100. So I'm matching these two numbers so that it goes down to the bottom. Okay, so we have a bunch of rectangles. They obviously don't stand out from the trees from the background because I use the same color. So let's get some more colors in here. Oops, HTML color codes. Let's see. Brown. Let's get something a bit darker. Rosy brown kind of looks nice. Oops, rosy brown. Okay, that looks all right. Oh, I do have to move this farther down because I'm doing center, or I guess it's, yeah. Okay, so those are our trees. And then we could do different things for the tree leaves. We could do triangles. We could do circles. I'm going to increase this a bit. And let's start it a little bit inside. Okay. And so then whatever you want to do for our tree leaves. And so then just to keep things simple, I'm just going to put a little ellipse at the top of the tree. So I'll use x height minus 50 again. And then let's just try 50 for the size. And let's change the color. So I'm going to do fill green again. And then we got to do height minus 100 actually, because our rectangles are actually rect mode center. So that lines up. That looks pretty good. And then if you wanted to, you could change something. Like we could make the height on the trees bigger. Kind of looks kind of funny. I don't know. Whatever you think looks good for this design. And they are overlapping. So if you wanted to make them not overlap, we could increase this number, the increment, until we get something. But I kind of like the overlapping, so I'm going to leave that like that. And then let's do our clouds as kind of the last one. And we'll do something a little bit different here. So I'm going to do some clouds. So I'm going to say for let x again, and maybe we'll start at like 50. X is less than width. X plus equals, I'm not going to do too many clouds, so I do x plus equals 100. Then I'm going to do fill is white. And I'll just draw an ellipse x, and I'll do like 100 for now, and like 50, and just take a look at that. Okay, so those are kind of like regular clouds. And so one thing that you might want to do if you have like a bunch of things that you want to make it look more like a cloud, let's just like move this ellipse a bit. So I can add a couple more. I'll do plus 50, and then I'll do like 150 here. And actually, let's do slightly smaller. Okay, so you can kind of like create a bit more going on with the clouds. So maybe for this one, I'll do like minus 20 on X and 140 on Y. Actually, let's go the other direction on Y. So they're all kind of the same, which is something that we'll fix in the next video. We'll be able to do some variation, but you could play around with that until you get some nice clouds, somewhere that you like. Maybe we can move this a little bit. Maybe we can move up a little bit. So let's do like, well, actually I'm gonna leave that, that's fine. So yeah, we have some little clouds with some variation. So that's kind of a nice, actually I'm gonna do this even more. I don't want quite as many clouds. Okay, that looks a little better. So we can do some simple variations if we want. We'll get into like better ways to do this, but one thing to keep in mind is that this x value is changing, and so we can use that to show changes, but we can also change other things over time. So for example, let's like make our mountains change color across. So I have this fill as brown. So if I look at what brown is, it's RGB 165, 42, 42. So let's fill that in instead. So 165, 42, 42. We've got that brown. So what if I wanted to change that over the space of X? So if I just put like X in here for the red, now see how it goes from one color to the other. You might remember from our first lesson on interactive events that we don't want to, just use X, because X is going like all the way across here, whereas our color value really only goes to 255, which is somewhere like right here. So that's why these last three are just like purely red. So that's somewhere where we can actually use the map value. So we could say let R for red is map X, and instead of mouse X, we're just using X here because it's changing. And then we can go 0 to width, 0 to 255, and then we'll use R instead of X. And now we'll see that we kind of go from green all the way to red over here. So we can get kind of a nice little effect there if we want to change the colors. We could also do that with some other colors. So if we wanted to do something with the trees, maybe we could do something with the green. So we have green. Let's look up the values for green. Green. So that's 0, 128, 0. Okay. Okay, so then what if we have like let G, and then we can map X again from 0 to width to 0 to 255. And then let's put G in for our green. So we can see over here that it actually starts at like black, which when X is 0, green's going to be 0, and green's really the only color we have in here. So if we want to avoid that, we could start it at like 100. So it starts at kind of green and it gets to brighter green. This we might think is like too bright, so we could switch that to maybe 200 so it doesn't quite get so bright. And then, maybe we want the gradients going in opposite directions, so I could swap these. So now our gradients are going in different directions, which might make sense or not, depending on what you like. So we can add some kind of like simple variations. We can also do it like in terms of position or size. So for our clouds, they all have the same size here, and the y is kind of the same. There's a little bit of difference. So let's figure out what that would be first. So let y would equal 100. So then we'd put y here, and then this would be like y plus 20, and this would be like y plus 10. And so then if we change y, we'll change the position of the clouds. And so because we're kind of like working with this like linear thing, we can't really make them totally all over the place, but we can at least make them go in one direction or another. So one way I could do this is I could map y to x, or I could just move this let y up here. And since let y is declared before we go inside the for loop, y will still exist inside this context. So if we have let y equals 100, and then we could just do something to y. So we can have this kind of like sub iteration happening inside of our loop. So we could say, y plus equals 10. And so then we'll get the clouds kind of going down. Or we could do minus equals 10 to get the clouds going up. Maybe let's get our last group of clouds in there. Yeah, there we go. I can make it more dramatic if I do 20, or maybe somewhere around 15 is good. Or we can reverse it again and then change where it starts. So maybe it starts at like 50 or even 20 instead of 100. So we can do different things to kind of create some variation. Because it's kind of like moving in one direction, like each cloud gets farther down the page, it looks a little bit like artificial. And so in the next video for this week, we will talk about how to create some randomness with our pattern. And so we'll create another version of this project in that video. So let's save a thumbnail of this, and so we can add a link. Okay, so here's my pattern version 1. And I'm going to drag that in there and just call this thumbnail. And so then we can update our home page. So I'll go home, and I'm going to add a link. I'm not sure exactly how many of these versions I'll have, so we might need to update this later. But for now, I'm just going to go to the index page and copy this project. And so now we're on a different project. So I'll delete this thing here. So this one is pattern v1, and pattern v1 is the link, and pattern v1, and then this is the for loop. So let's see how that looks. That looks pretty cool. Okay, so if we click on there, we see that looks good. So that's great. Let's go over to GitHub and just say add pattern v1 and commit to master and push to origin. So that's it for this video. In the next video, we'll introduce randomness. So we'll be able to add a little bit of random elements to our scene to make it look a little bit more natural and a little less predictable. So that should be fun. So let me know if you have any questions on Discord or email, or talk to me in class.